guys, welcome back to my channel Communicate, and I am really excited for this video because this is like the most awaited video. I really wanted to do this from a long time, but I think this is the right time when I start making the video on this topic. So we are going to kickstart making the videos on DFT calculations, and today we start with the first step of DFT calculation, that is the Gauss view. So I will use Gauss view to design and make the molecules ready for the DFT calculation. So this is just an introductory video to get you guys familiar with the software and how we move forward with it. So without wasting any time, let's just start it. Okay, so this is how Gauss view looks. I'm using Gauss view 6 here. This is the interface, how this program looks like. So since this is just the first video, so in this video I will just show you how to play around with this software, how to use the basic functions, how to draw the molecule, and just to get you familiar with this software. All right, so let us just get started with this quickly. So first of all, how do we draw a molecule in this software? All right, so I will start with a very basic molecule. For example, here if you go on this tab here, you see the periodic table opens up. Now let me choose like any element. For example, phosphorus. I choose phosphorus and I want to draw the tetrahedral phosphorus, so I choose this. And your drawing board is this white portion here. All right, so when you take your cursor here and then click, so it will draw the molecule. Okay, and then drag your mouse around and it will rotate the molecule in whatever fashion you want to rotate it. So this is the molecule we have. So it has now drawn pH 4 for us. So these small gray balls here represent the hydrogens, and this orange ball here represents the phosphorus. Until unless you do not put any other element here, this represents the hydrogen for you. All right, now for example, if I want to substitute this hydrogen with, for say, chlorine, how do I do that? All right, so again I will go to this section here and open the periodic table, and I will choose the element chlorine from here. Okay, and then I close it, and then I will take my cursor on this ball, gray ball, which I want to replace with chlorine, and then I click it. See? So now this hydrogen is changed or is substituted with chlorine. All right, let us just rotate it and see. So now one thing did you observe? The bond length of the phosphorus and chlorine bond is clearly different from the bond length of phosphorus and hydrogen here, right? The PCl bond length is definitely is different from the pH bond length. Now if I want to see that what is the bond length, that also we can estimate in this software Gauss view. How do I do that? So for that, you go on to this small button and click it, and when you do so, uh, then you drag your mouse and click on this atom here, and then click on the another atom like between which you want to calculate the bond distance. Okay, and click on this atom. See, so now it shows me the bond distance between these two atoms, 1 and 2, which is 2.04. All right, now you can okay, let us go stepwise. So this is for the single bond length. What if I want to draw a double bond between this? So that also we can do from here. Now if I choose this option of double bond, so now it has created a double bond here, and if I want to create a triple bond, we can do that as well. All right, and we can also increase and decrease the bond length according to our wish. If I drag this here, now see, the bond length is decreasing, right? And if I want to increase the bond length, then I have to take it to the extreme this side, and then the bond length is increasing, but we will bring it back. Okay, now for example, I don't know the bond length of PCl bond. Okay, so let me just make it random, like long like this, which it should not be. So basically, if I am an amateur, or just if I want to see like how can I correct the bond length, so let me put it in this fashion. Okay, So now you see this is weirdly long. Ideally, it cannot be like that. So how can I polish my molecule, right? So there is this very nice option here. You see a little broomstick button here at the top. So if I click on this, it will automatically resize my molecule, reshape my molecule in an ideal way according to this software, like chemically how it should be present. All right, so this is how you can do it. Now for example, now again I want to change this triple bond to single bond. Then how do I do that? Now see, this option is already selected, so I do not have to select it again. I just have to click on the atoms between which I want to change the bond length. So I click on atom 1 and then atom 2, and I want to change it to single bond again. Okay, so I press OK, and let me polish it once again with this broomstick. So it creates a little bit different. Why? Because of course it has made the bond length longer, because now it is a single bond length and earlier it was a triple bond length, and as we know that the single bond length is greater or longer than the triple bond length. Okay, so this is how we do it. Now for example, if okay, I am not interested in this molecule anymore. If I want to delete this molecule from my working page, so how do I do it? So now there is this option called cross here, right? I want to click on this, and then it gives me a small option box which says that do I want to delete this molecule. Just press OK and it will clear your working space. Okay, now for example, I want to draw a big molecule, something which includes some aromatic systems. Now if I want to draw a benzene, I can, it is very tedious if I draw it manually, right? So there are some options in which already some of the aromatic systems or some of the rings are already made, right? So for example, there is this option called benzene here. If I click on this, it will open me this tab which is having a multiple options of different type of systems, different type of rings, aromatic systems, and I can choose from that. So for example, I choose benzene here and now click on this white space here. So see, this has now created benzene ring for me, right? This is how it looks. Uh, Now, for example, in my benzene ring, I do not want to see these hydrogen, because for me, if I already know that, okay, the hydrogen are present, but I do not want to see them in my molecule. So that can also be possible that you want to hide these hydrogen atoms. So how do we do that? So now you go to this option called view here, and see here, there are certain options, and there is this one option called hydrogens which is ticked right now. So you have to untick this option. When I do that, you see these hydrogens are now disappeared. You cannot see the hydrogen. It's not that they are not there, it's just that you cannot see them. All right, for example, when you draw the benzene molecule in your notebooks, you do not draw the hydrogens. It is understood that they are present there, but you do not want to show them. Just like that, we have hidden the hydrogen atoms from here. Okay, so let me just put the hydrogens back here. Yeah, so this is how it looks back in its original form. So now, for example, if you want to substitute these hydrogens with some other functional groups, right? So that is also possible, and it's very easy, just like we did a few minutes ago. We will now again go to this periodic table option, and for example, I want to choose oxygen here to put alcohol as my functional group. So all you have to do is go to any hydrogen atom and then click on this, and you see now it is now replaced with an OH group instead of the single hydrogen atom, right? So likewise, you can actually put any element, any atom of your own choice. Let me do it once again for you. Let us select another atom again. Let's say nitrogen here, and we now click on this one, and you see this has chosen NH2 group here, right? Now, for example, if I want to delete any particular atom instead of the whole molecule, if I want to delete the whole molecule, that I showed you that you have to go on to this option called cross. But I don't want to delete the whole molecule. I want to just delete some particular atoms. That is also possible. For that, you have to go to this option here with a small little cross and then select it. and then go to the atom of your choice that you want to delete. For example, I want to delete this oxygen atom, and when you will delete this oxygen atom, it will automatically delete the hydrogen associated with that or attached with it. So let me just click on this oxygen atom. When I do, see, now it is removed. Now for example, I do not want oxygen here, I want to put sulfur here. That also I can do. Again, go to this periodic table option, and now I will choose sulfur. All right, now again cross it and click at the extension of this bond here, and now you see sulfur atom is drawn, right? This is how you do it. So next is, you can also measure the bond angles. I showed you previously that you can measure the bond distances. You can also, change the bond distances between two atoms. Likewise, you can also measure the angles which is present in your drawn molecule, and you can also change the angles between the atoms. So for that, there is this option here. So you have to select this option, and then uh, select any three atoms in which you want to measure the bond angles. For example, I select these three atoms here. So you see now this box has appeared on the screen, and right now the way this molecule is drawn, so this in between these three molecules, sorry, between these three atoms, the bond angle is 109.5 degrees. And if you scroll this here, you can also change the angle between these atoms. Right now, you see, when I scroll this, it is moving in one particular fashion. You see this atom 2 is not moving, so this atom is now fixed here, and these two portions are moving. So this you can change from this portion here on this box. So you see this atom 1 is rotate group, atom 3 is rotate group, but atom 2 is fixed. You can change this. Maybe if I want to keep this atom 1 fixed and want to move them, we can do that as well. For example, I make now this atom 1 fixed, and now let us try to scroll this. So now you see only this atom is moving, right? So according to your convenience, or whatever way you want your molecule to form or see, you can choose these options according to your own needs, right? So let me just do OK, and this is how we do it. So there are several options. These are just a few options that I have showed you right now. There are multiple options. There are multiple of things that you can do with Gauss View. So since this is just the beginning and this was just an introductory video, so I hope that you have got a feel of this program Gauss View, and it is not a difficult software. It is just this is just a program to view and draw your molecule to make it ready for your calculations. So with the further videos, we will make some even more difficult molecules, some even bigger molecules, and see how to work around with them. So I hope you enjoyed your first session moving towards the DFT calculations, although we didn't do any calculations in this one, but this is the beginning. This is the first step towards the calculations. So I hope you enjoyed it and learned and had fun with this. So I'll see you in the next video. Till then, keep learning, keep researching, and keep enjoying. Bye bye. See you next time.